Well, thank you, Tobias, and it really is a great pleasure for me to be here, and I learned a lot yesterday because the disciplinary mix is different to much of the interactions that I normally have. And so I'm hoping that we can have a discussion afterwards. Now, I don't want to waste too much time on introductions, so I'll get straight into my talk. I hope. This is a little aquatic fern called Salvinia molesta, and it's native to South America. But in the 1950s, it somehow got into Australia, and it just took off and covered lakes like this. And so a scientist from CSIRO went over to South America and studied it, and he found there this little weevil, Certobagus, and the Salvinii tells you that it actually only eats the Salvinia. Now, we thoroughly tested that before bringing it to Australia, and it did only eat Salvinia, so we brought it in, and that's that same lake. A few years later, it worked like a charm. I didn't eliminate it. They went down to very small levels of each, and they sort of stuck in a stable, small level of equilibrium of the two. But the same weed got into lakes in Papua New Guinea, just north of Australia. So they introduced the weevil, and it failed, just died out. So the scientist went up and had a look at it up there. And what he found was that the level of protein in the leaves of the weed was just below the level needed for the weevils to reproduce. So they fertilized the lakes with nitrogen, and that brought the protein level above that critical threshold. The weevils reproduced, took off, and the same result occurred. All of the lakes were clear again. And then something that surprised them, but was very interesting, they found, they never had to fertilize the lakes again, because in very small levels, the rapidly growing new leaves of young plants, in any case, had a high enough protein for the weevils to reproduce. So there's two lessons that come out of that. The first really is that there are threshold levels in the dynamics of complex systems, and the systems behave very differently on either side of that threshold. Now, that's not surprising to you, but I want to make that first point. The second is that these threshold effects are caused by a change in feedbacks. Originally in Papua New Guinea, the effect of the weed on the weevil was negative. It died out. And the effect of the weevil on the weed was zero. But once that got above the protein threshold, then the effect of the weed on the weevil was positive. The weevil took off, and the feedback effect of the weevil on the weed was strongly negative. And so there was a change in the nature of the feedbacks, which then caused that flip. And in all thresholds that are crossed, that I've studied and know of, and others have, the threshold crossing is associated with a change in feedbacks. And it puts a special focus on trying to understand the feedbacks that are important in ecosystems. This is two states of rangelands, semi-arid ones. This is in Australia, but they occur in Africa and America. And the one everyone wants is this nice grassy state for livestock to eat, but it can go into this woody, weedy phase. Normally, there's enough grass to accumulate a fuel load so that there's a fire hot enough to kill the shrubs. Fire kills shrubs, but not grass. But if you graze that grass too much, that doesn't happen. And what happens is that as the shrubs' levels increase, because there hasn't been fire or anything, the equilibrium amount of grass that can be maintained gets smaller and smaller and smaller. When it reaches some point like this, the equilibrium is really very low, and then the shrubs increase. Now, if you want to get rid of them and you start getting rid of the shrubs, it doesn't go back to the grassy regime at that point. You have to reduce the woody regime much beyond that before it'll go back up into that grassy phase. I won't go into the reasons for that. It has to do with competition between established and establishing plants and so forth. But the point I want to make is that between these two levels, there are two alternate states that system can be in. For any particular level of shrubs, it can be in this grassy amount with that amount of shrubs, or this grassy amount with that amount of shrubs. And it's separated by this unstable equilibrium threshold. If it's just above that, it'll tend up that way. If it's just below, it'll tend down that way. So anywhere between these two, that system has alternate stability regimes on either side of that threshold. So system dynamics around a threshold can involve what's called a hysteresis effect. That's what that's known as, different pathways of going in recovery. And if it does involve hysteresis, then it puts a special focus on the importance of that threshold because it's much more difficult to manage. So some thresholds you have to ask, is there likely or is there a hysteretic effect associated with that threshold? These are alternate states of coral reefs. That's the one we all love with pretty colors and fish. But all too often, coral reefs are becoming this fleshy algae-dominated system. Much of the Caribbean now looks like that. And there are two thresholds that are important in this system. The first is associated with extra nutrients flowing into the reef from the land, from agriculture, sugarcane farming in our case. The nutrients favor algae, but not the reef, not the coral. So above some level, over time, little changes in bare bits of coral will get completely rapidly invaded by macroalgae and the system flips to algae. The second is fishing pressure, which is happening all over the reefs. Herbivorous fish eat algae, and they keep them at very low levels, and therefore you retain a healthy coral reef. But beyond some level of fishing pressure, it'll flip. Now, the important point here is that those thresholds interact. They're not independent. The more fishing pressure you have, the less nutrients is needed to push it across. And the more nutrients, the less fishing pressure. So thresholds can interact. And another thing that's happening there now is the effect of increasing CO2 and global warming. As the oceans warm up, they favor macroalgae over coral, warmer waters. As CO2 gets absorbed, it makes the water more acidic, which is very negative for coral reefs with their calcification process. So as with global warming is occurring, both of these thresholds are moving in. And so the safe operating space, if you like, of that healthy coral reef is getting smaller and smaller as global climate change increases. The 2 points that emerge from that is thresholds can interact, and thresholds can move, and they can be moved. Now, Michelle gave us a nice example yesterday about how you can move them in a positive way using funny structures underneath a bridge that enables them to actually have a higher level before the bridge collapses of some earthquake effect. So you can move the threshold of safety upwards. In this case, it is being moved downwards, but thresholds are not constant. They can move without you being doing anything, or they can be moved. Social systems and technicals have lots of thresholds and tipping points. I don't want to spend time here, but individual behavior, psychologists have done a lot of work on shifts in identity, and there are very clear threshold effects where a person remains okay, and then they go into a kind of catatonic state beyond some threshold of change. Crowd behavior, riots is a common thing. Up to some level of a percentage of a crowd that's rioting, if the cause goes away, the riot dies away. But above that threshold, even if the cause goes away, it goes into full-scale riot. So that behavior is a tipping point in crowd behavior. Economic systems, labor supply has thresholds for an industry. Debt-to-income ratio has a threshold for a business. Infrastructure systems, and I'm not going to tell you people about that, but transport, communication networks, and lots of other things have threshold levels in them. So thresholds are really common. But there's a danger in focusing on a particular known threshold, and this is often done because it's important, and all the effort goes into that. Making a system resilient in one way can cause it to lose resilience in other ways and at other scales. There are trade-offs in applying resilience. So social, ecological, and linked social ecological systems, they are complex self-organizing systems. And you cannot predict outcomes of any particular intervention in a complex self-organizing system. Therefore, it's necessary to build what we call general resilience. And general resilience is the ability to cope with whatever might happen, any part of the system. So what kinds of attributes confer resilience in general? What I'm going to give you now is a number of attributes, and they come out of a number of studies, a cumulative of a lot of them, and we sort of put these together over the years. And top of the list is high diversity, and I mention here especially response diversity. I think sometimes it's called redundancy. In an ecosystem, an essential function is fixing nitrogen, and that's done by legume species. Now, if an ecosystem has one legume species, as long as nothing happens to it, it's fine, everything goes well. But if that legume gets eliminated, a disease or fire or something, then the whole function of nitrogen fixation is gone. If there are 10 legume species, and they're all fixing nitrogen, but in different ways and different responses to environment, if something knocks out 3 of them, there are a bunch of others that'll keep going. So the function of nitrogen fixation is more resilient. Now, sometimes I think it's got redundancy. Well, redundancy has a negative connotation about it, so I like to call it response diversity. Variability, allowing a system to vary rather than trying to control and reduce it. I'll come back to that a bit later. Being modular, not over-connected or under-connected. Fully connected systems are very vulnerable to something bad coming in. A disease, a bad idea will spread right through the whole system. And underconnected systems lose the value of connectivity. There is an intermediate degree of modularity, which is sort of tightly interacting subsets that are loosely connected together. Something like that in the middle is the best and most resilient system in terms of connectivity. Hard to put a number on, but you can sometimes know whether it's under or over-connected. Being open, allowing emigration and immigration. Closed systems tend to stultify over time and lose resilience. Being able to respond quickly to disturbance, the thing that's often called about is having tight feedbacks. Now, one of the worries in today's world is that with fear of litigation and occupational health and safety and all the rest of the things we're doing, there are now so many sign-off points along a track after something has happened that by the time the manager gets permission to do it, either the opportunity or the crisis has happened. And so this feature of today's society of too much safety is slowing down the needed quick response that you need for resilience. Having reserves, have like seed banks in ecosystems or memory in social systems, those reserves confer resilience. Fostering learning, innovation, and novelty comes up again and again in the way social systems in particular remain resilient. And the last one I put up is social capital, and 3 things keep emerging in studies of what confers a high level of social capital. And it's trust, leadership, and social networks. Those 3 things seem to be very important in conferring social capital. Okay, general resilience, as I've just been describing, is more or less equivalent to what's sometimes called adaptability, sometimes coping capacity. But let's think about it, the adaptability side. Does further adaptation in a system to keep the system in its current state with its identity, does that simply amount to digging the hole deeper? And I'm sure most of you here would know the first rule of holes, but for those who don't, the first rule of holes is that when you're in one, stop digging. And this is what happens when you keep trying to adapt, and the system is getting worse and worse as you do it. So if a shift into a bad state that you don't like has happened, or it's inevitable and it's going to be irreversible, then the only option is transformation. And transformability is the capacity to transform into a different kind of system, a new way of living, and a new way of making a living, when adaptation is no longer possible or desirable. Now, resilience and transformation are not opposites, which sometimes people think they are. They are, in fact, complementary, and especially maintaining resilience at one scale can often require transformational change at another scale. I'll use the Murray-Darling Basin in Australia as an example. It is the kind of heart part of irrigated agriculture in Australia, very, very important. But there's not enough water in the Murray-Darling Basin to keep all of the existing irrigation schemes going. The water licenses were allocated in the middle of last century when water was more prominent and we didn't know too much. So they were over-allocated. If they all keep doing what they're doing, all of them are losing resilience and becoming vulnerable more and more to droughts. The only way for the Murray-Darling Basin as a whole to remain a resilient irrigation agricultural system is for some parts of it to transform into non-irrigation, dryland agriculture, livestock, tourism, or whatever. Now, it's very hard to do. The NIMBY thing comes, not in my backyard. Someone else can stop. And it's very difficult to get that done. So transformation is not easy. So what are the determinants of transformability as opposed to adaptability? Well, I don't have a lot of time, so I'm just going to put 3 things up here. 1, accepting that change is necessary. Getting beyond the state of denial. And it is really difficult for that to happen. People refuse, they don't like fundamental change. And they'll keep trying to do what they do. Governments keep trying to keep them doing what they do. If you do get over it, then options for change. What are there? How do you find what other things to do? Sometimes there are examples from elsewhere, or you can conduct what are called safe experiments. Try new things at small scales so that they're safe if they fail, but then let them grow when they work. But there's a whole host of things under creating options and finding options for change. And then there's the capacity to change. The first thing is the levels of capitals. If there's lots of good natural capital and lots of social capital in the system, it's going to be easier. You'll have a higher capacity. And then help, usually from above. Financial help is obvious, but policy help is often crucial. Changes in the rules and regulations of how and what you can do in using resources are often necessary for a transformational change. So it's help to change, as opposed to help not to change. Okay, having put that across to you, the 3 elements of resilience then have to do with thresholds, the resilience of what to what. We call that specified resilience. And there's a huge amount of work done in that, and it's obviously something that you need to undertake if you're doing a resilience analysis. General resilience or adaptability is the second, and transformability is the third. Those are the 3 elements that collectively constitute what we would call a resilience body of work. So what is resilience after all of that? Well, this is the definition that we, being the Resilience Alliance and colleagues and others have come up with, is the capacity to absorb disturbance and then reorganize so as to retain essentially the same function, the same structure, the same feedbacks, to have the same identity. And when necessary, it is to undertake transformational change into a different identity. So what's missing in resilience theory and practice as of now? And the things which we really don't know how to deal with, and I'm saying we, me and the colleagues and work in social ecological systems, is the roles of power in politics. And I don't have time to go into that. That's a workshop on its own, and I hope that you can attend to that in some ways, because it is really difficult to address. Just quickly, power. 10% of the world's corporations generate 80% of all profits globally, et cetera, et cetera. We can see this incredible concentration of power all around at various scales. Now, the current effects of that power concentration, generally speaking, on resilience are negative. But they could be positive. And we don't understand enough about how power works and how we can interact, how we might be able to influence it in some way. But, for example, when the world's largest retailer committed to certified seafood. That act catalyzed other retailers and triggered a rapid increase in certification, which was hugely important for the resilience of the seafood industry. So power can be good, but very often it isn't. How do we deal with that? It's an open question for you. Politics. This is a remote sensing photo of the Amazon basin, a part of it, in 1975. And that's the same area in 2001. And you can see all of the access lines for timber and forest clearing, but also for conversion into agriculture, particularly soybeans. Well, literally those two, and plus others, remote sensing, information like that, was shown all over Europe by conservation groups. And it stopped Europeans from buying soybeans from Brazil. And that action led the Brazilian government to ban forest clearing. But I think you've all read, the new president has just overturned all of that, opening it all up to logging and agriculture. So how do you include politics when it's so unpredictable into trying to get a resilience framework to make the whole thing more resilient? Okay. Applying resilience theory, then, how do you develop a resilience program? There are two that I can describe in some way, but I don't have the time to do that. The first is the one I'm involved in Australia. It's the Resilience, Adaptation Pathways, and Transformation Assessment. It's a bit of a mouthful. We call it RAPTOR. It was funded, and it is funded by the Global Environment Fund and by UNEP to start with, to help developing countries initiate and find a framework for applying a resilience approach to their development. The other one is called Wayfinder, and it's been developed in the Stockholm Resilience Center. If you click onto the Stockholm Resilience Center website, you can find Wayfinder, and it's a kind of an internet-based way of dealing through how you might put into practice this Wayfinder thing to find resilience. Let me just go back a bit to the RAPTOR one. I wish I had more time. But if you find this link, it takes you to a paper, which is a kind of a short summary paper of the whole approach and gives you a pretty good overview of what this RAPTOR is all about and how it works. Very briefly, the first step in it is effective engagement and legitimacy. And what we found is if you do not have all the necessary stakeholders at the table in the beginning, you'll fail. Because those that aren't there will scupper whatever you're trying to do, and it won't work. So getting legitimacy for what you're doing, what the objectives are, what the problem is, getting a clear understanding of it all, and that takes much longer than you think. The second then is the resilience analysis. Now that involves describing the system. What is it? What's in, what's out, what scales, how do you do that? And then how do you apply the resilience assessment? Are there thresholds? How would you find that about? What are the weaknesses in general resilience? You do a resilience analysis and describe it. And the third one is then options and pathways to action. Having done that, where is the best place to intervene and to start? This often involves sequencing. You might have to do A before you can do B, rather than start on that. How do you put together a program of interventions? And this is where this pathways comes in, and adaptation pathways, and all of this. Let me just finish by saying all of these are very strongly influencing and influenced by the adaptive governance of that project and program. This is never ending. You will never get it right. There is no right thing. Bureaucrats hate that. They've got like a 5-year funding program and you've got to have it and that's that. Well, when you tell them, no, that's not that, this thing will never be right and it's got to go on and on and on, oh God, you can never get past that. But anyway, that is an ongoing learning process of applying resilience. And that adaptation pathways here is very important because it's a way of finding how you move forward in time, correcting, and that what it says is that never try and pick the perfect future. You never will get it right. If you try it, by next month it's no longer the perfect one because the world has changed. So what you do is you find all the okay states that system can be in, and you let it self-organize through time. But you find the boundaries that should not be crossed. And you intervene to keep them within that set of okay adaptive system states and let the system self-organize along it. I wish I had more time, but I don't, so I'll go straight on now. To finish up with some lessons that we've learned along the way about resilience and how you apply it. First of all, resilience as such is not good or bad. Everybody kind of assumes that you want more resilience. Well, salinized landscapes and evil dictatorships and others can be very resilient. Resilience is simply a property of a system. It is not good or bad. And a desired state can become undesirable through changes in external conditions. Now, I know some of you have heard me say this before, but resilience is not the ability to bounce back to what it was before. It irritates me when I see this because it's a misunderstanding. In fact, I keep hitting the wrong thing. I'll get it right shortly. What's happening here? Oh, there we go. In fact, it's the ability to adapt and change and reorganize while coping with the disturbance. That reorganization enables the system to remain and become more resilient to the same disturbance next time. Bouncing back means that you do exactly the same thing and you haven't improved or changed at all. So resilience is very much about reorganizing in response to a disturbance and becoming more resilient by doing it. So resilience is not about not changing. Bouncing forward, this came up yesterday. I don't really like that, but I've been thinking about, well, if it is it, could you perhaps say that that's equivalent to a transformational change to the forward part instead of going back? Well, in that case, I'd call it vaulting forward or something because it wouldn't be a straight line. But anyway, that's a messy area for me, and I'm not too hung up on this idea of bouncing forward. Preventing disturbance and keeping a system constant reduces its resilience, and that is so often what people try to do. A forest that is never allowed to burn, it's kept fire out of it for the reasons of good forest management, over time, lose the species that are adapted to fire. And when one does come, the whole forest is destroyed. The only way for a forest to remain resilient to fire is for it to be burned every now and then. Children who are prevented from playing in dirt grow up with compromised immune systems and then develop all kinds of allergies later in life. The only way for a person to become and remain resilient to the environment in which he lives is to be exposed to that environment. Probing the boundaries of resilience is necessary for maintaining and building resilience. You cannot understand or manage resilience at one scale, and this is so commonly mistaken. There's a problem, it's at that scale, all the attention goes into how you fix it at that scale. But very often, it's the interactions across scales that are critical to the resilience of the scale at which you're interested in. So always keep in mind the cross-scale connections and the necessity to look at scales. So I'll finish with a very brief summary. Resilience is largely about learning how to change in order not to be changed. And try to build systems that will be safe when they fail, rather than fail-safe systems. Assume failure. Thank you.
Brian, really outstanding, very, very, very helpful, and I think a perfect illustration of, when we have a disciplinary perspective with all the insights that comes out of your social economic work, how powerful that can be for those of us who have been thinking, in my world, in the political side. So that was one that you laid off. I'm teasing in real time because the presentation really helped to stir this. Attention of the last piece, one of the observations which you said is good resilience is not necessarily good or bad, right? And you made the case of a dictatorship can be quite resilient, or We sometimes define terrorists as we're quite resilient. We keep whacking at them and they come back. If we talk about resilience essentially as having all these attributes to really get to describe this state which you've laid out, that could be neutral. But where I start to see the political value of the good side is the only way I know to achieve both this adaptive and transformational capability is essentially an open democratic community engaged process with a high degree of social capital. And that's good. So so part of our message and struggle here is to say, all right, scientifically I get this neutrality, but I'm really wanting to apply this value of resilience as a good that we're trying to get to, because I know the ingredients for it to actually make it happen, to have those conditions is not a dictatorship. Is not a, so that's a tension. And so I just wanted to get your reaction to that one.
No, I understand it, and in most cases, we are trying to build resilience in a good way because we want the particular state of the system, its identity to continue, and it's threatened in some way. But it's never to forget that, in fact, resilience can be negative as well, and it can be a very bad state of the system. So the political part is really the very interesting one, and how do you try and build this in so that the whole system has a kind of a resilience flavor to it? Now, a benign dictatorship would work. So when they make me president of the whole world, we'll be okay? But the trouble is, of course, once you do get one, they'll become non-benign. And that's the difficulty. So I couldn't agree more with you. You have to have some kind of a democratic process. But the elements of that democracy have to include and be based on a lot of resilience thinking. And the elements of the democracies that I'm aware of around the world do not. Some, by chance, include a few of these features, but none of them address them specifically and say that in this country, or the way we're dealing with it, these are the things that we should be trying to do. And those features should be not equated to respectful life and human life and all of those things, but they should be in there, and they're not. And we have to get that across to the general public. And now I hate to make this sound, but I've just put things out there of a book I've just done because I'm so irritated over the years about people in the public don't understand any of this. We scientists spend our times talking to each other, and it just gets more and more complex. But you go outside and ask people, and then the Tower of Babel that mentioned earlier yesterday, to me, resilience is becoming just nothing because it's used by everybody in different ways. So somehow we have to get our message over to the general public that they begin to understand what resilience is and the elements of it. And I've tried to do that in that book. But I do think beyond that, it's sort of the duty of all of us here to spend some of our time trying to figure out how we get this message across to laypersons and the general public, because we'll never get the democratic system working with a resilience basis unless we do that. Sorry, that was a big reply, but I feel quite deeply about it.
Oh, thank you. Thank you so much. I want to ask you if you have any examples, because of course political issue is, in my opinion, the most important issue. So you can apply to people, please be able to change your system, your behavior, because people don't like heavy changes. But once the regulation come, they have to change.
Sorry, once the?
Regulations.
Yes.
Yeah? Then they have to change. Yeah. This is like you have a red cross on the street, so people have to stop. You can't discuss with them, please stay or not, or go. So regulation must come. Do you have any, or a question to the audience, do you have any examples of how did you, or how you think to achieve politicians to force them bring regulation into the resilience, even if we don't want to talk about the resilience and bring people to different pictures in their mind, but even if we have a picture in our mind to implement the resilience in our system, me as the water supply, you as different users or researchers, but if you have any examples how you could convince politicians to do, please, I would be happy to know that.
Well,
even in Europe, we don't want to go to Brazil, okay?
No, I can't answer that offhand, I'm afraid. There will be some where it's a particular thing that you can do for a particular kind of threshold, and those regulations can be brought in. In fact, we've done that in Australia for certain levels, for example, of clearing land below which we know there's a threshold at about 20% of native vegetation in a landscape, below which there is a sudden major drop in the number of native species that can persist. So a number of states have started to implement that into their land clearing laws. So those sorts of things can come in, but those are specific and interesting. What's much more difficult is to try and get the notion of resilience across into politicians, because it isn't fixed. It is always varying. It's always changing. And they just think, oh, you can't, it's no good talking to you. You can't put numbers on it. You can't manage it. Therefore, it's silly. And yet that is resilience. It is very difficult to pin down in some particular set of constraints. And I don't know how we do that. Individually in bits, I think we can do it. And like the example I just gave. But an overview to say, change your whole mindset from the way you're structured to think more like a resilience one, that's really awkward. If I'd had more time, I actually had a slide up there of how the Golden Broken catchment in Australia has changed its whole focus to resilience. And what they've got, they no longer look at their catchment as this place grows this crop and that place does this and this. They've now got a set, and they've got, I think, 13, no, it's even more now, it's about 18 identified thresholds that they're concerned about. Social, ecological, all sorts at different scales. And their view of their system is now a system of interacting thresholds. And their whole board now is beginning to think that way. It's taken 10 years, but it's worth trying to get that image across.
Thank you very much, Brian. I mean, that wasn't only keynote, but also a call to the flag, and you've given us a huge task to educate the public and the politicians.
Okay, thank you.
I hope we can take up that flag. Thanks. Thank you.